Okay, so the first part of the question, part A, if you'll have graph paper nearby, I would strongly encourage you to pull your graph paper across, and you could follow along and you could do the question yourself, so that way you'll get a feel for what this type of question will entail. If you don't have graph paper and you just want to follow along, just you could sketch a diagram as we go along, so you'll have a fair idea as to what is going on, right? So the first part of it says, using a scale of 1 centimeter to represent 1 unit on both the x and y axes, draw on graph paper the triangle PQR, and then P prime, Q prime, R prime, such that, and they give us all the coordinates, alright? I'm not gonna even read it out. But the first thing that we need to do is set up our x and y axes, because we have a shape that we're going to be representing it in the Cartesian plane, but they've also given us a transformed version of this particular shape. So what they probably want to identify here is whether or not we what type of transformation, I should say, what type of transformation has occurred with this particular shape. Alright, so for those of us who have graph paper and you're going to be drawing, right ahead, set up your axes. And for those of us who don't have graph paper, kind of did a little grid here so we can get started. Alright, now what we need to know is the coordinates of the shape PQR. That's how we're going to start with this problem. So I'm going to go back and highlight that information. Alright, so they said that the coordinates of PQR, P has coordinates -3, -2, Q has coordinates -2, -2, and R has coordinates -2, -4. So I'm going to go across to my grid and I'm going to plot those three respective points, starting with P, which is -3, -2. So -3, -2 over here. It's point P. They said point Q is -2, -2. So we look for -2. Oh my goodness, this triangle is extremely tiny. And then finally R is -2, -4. Okay, so now all I have to do is connect my 3 points and I will have my triangle PQR. Alright, so for those of us who are drawing the diagram or drawing in on your own graph sheet, this is what you should have for your triangle PQR. So in a little bit, we're going to look at, let me shift this a little bit. Yeah, in a little bit, we're going to look at the transformed triangle P prime, Q prime, and R prime. Alright, and then we'll plot those points as well. And then we're going to try to determine what type of transformation would have occurred. So when I come back to my information across here, it says that P prime is 6, 4, Q prime is 4, 4, and R prime is 4, 8. Let's go across to plotting these points, right? So P prime is 6, 4. P prime is 6, 4. So I'll use green to indicate this one, right? So 6, 4. Then we have Q prime 4, 4. prime is 4, 4. And, alright, yeah, let me label them. So this is P prime, this is Q prime. And then finally, this one is R prime, right? R prime is 4, 8. Okay. 6, 7, 8. Okay, we'll pretend that that's 8. We know it's not 8, but we'll pretend that it's 8. And this will be R prime. Sadly, my grid, I had extra space underneath. Goodness, I have to change everything now. Anyway, just wait with me on this one. So the people who have their graph paper, they'll be able to, draw it in properly. I'm just gonna have to kind of shortcut it and put R prime up here because not enough space. Anyway, so here we go. We now have the triangle PQR, we have the triangle P prime, Q prime, R prime. Alright? And I want you all, when you finish, so for those of us who are drawing a diagram or doing your own on graph paper, I want you all to take a quick look at the diagram when you're done. And I want you all to observe the triangle PQR versus the triangle that is transformed, P prime, Q prime, R prime. Alright, and I want you all to mentally list out your observations, and we're going to discuss those observations in a short bit. Alright? So, look at the diagram and make note. Alright? So I'll give you all like 2 minutes. Anybody drawing a diagram, by the way? And need time? Or everybody is just kind of like following along right now? Alright, nice. Okay, good. Nice. Alright. So, when we look at the diagram, anybody wants to tell me what they observe about the diagram? Nice. It is larger than PQR. Very good. That's a very good observation to notice off the bat. So, when you notice that the transformed shape is larger than your original, what comes to mind? What type of transformation comes to mind? It's an enlargement, right? So we can already tell based on what we're seeing here that PQR has been enlarged. Now, when it comes to enlargements, there are two things that we need to make note of, right? One of those things would be scale factor. And you all would have been accustomed to these from like lower school, right? They'll tell you that a shape was enlarged by scale factor, whatever, and then you'd have to probably obtain the image, right? So scale factor key. And when it comes to doing enlargements as well, we need to make note of the center of enlargement. So just like rotations, alright? So I just want to point this out. So just like rotations, enlargement has that center that the transformation takes place through or at. So center of enlargement is going to be important, and the center of enlargement is usually a particular point in the Cartesian plane, and we'll discuss that in a little bit. Alright, so let's just talk about the enlarged shape. Based on what you all observe, can you tell me what you think the scale factor might be? Alright, so 2. It's correct. It's 2. And you can tell that simply by comparing corresponding lengths in your original image and your transformed image. Alright, so if I compare PQ and Q prime, P prime, I can see that here the distance is 1 unit and here it's 2 units. So I can tell that the scale factor is already like twice the original shape size, right? It's a scale factor of 2. But there's something in particular about this enlargement that makes it a bit different. It's not going to be as straightforward as, okay, we had a scale factor of 2. Notice something with the orientation of the shapes. What can you all tell me is very outstanding about the way in which the enlarged shape looks in comparison to PQR? That's it. It's sort of flipped. Anybody here has ever seen anybody here could recall from physics in particular? I don't know how many people might recall seeing this or have heard of this, right? But images are actually like flipped versus how we think everything is upright, because our eyes actually flipping the images around us so that we will see everything upright. But in lenses in particular, anybody here doing physics and could recall doing something of this sort where they've learned about real images versus virtual images, and something that is real would actually appear flipped, but virtual images would appear on the same side in the same orientation. Alright, so that's just a little side note in case people know what I'm talking about, right? But when we deal with this particular type of enlargement in math in particular, an enlargement where the shape is now flipped means that you've used a negative scale factor. Alright, so it's good to, like I was saying, it's good to take note of all the things you observe, because that is going to help you with coming up with your solution. So here, because it is flipped, as you'll see, it's flipped, we have a negative scale factor, right? It's a negative scale factor. Alright, and the negative scale factor would actually be -2, and the reason why we know that the shape is enlarged by twice the original scale of the shape, but since it is flipped, this is the reason why we have to include that negative sign. So we're going to come into talking about the matrix in a short bit, but I'm going to talk about the center of enlargement now. Your center of enlargement is a particular point in your Cartesian plane where your transformation is occurring through, right? And to obtain the center of enlargement, in some cases it's pretty apparent where it occurs. Alright, in this case I believe it's through the origin, and to confirm that it is through the origin, what you have to do is this. You have to, I didn't click on straight line, did I? Moving along. Alright, so you have to connect corresponding points from your shape, from your original object to your image, right? Your enlarged image. And this line will be a little bit off simply for one reason, because I squished that point into the space that I have, right? But for those of us who actually have graph paper, when you do this, I want you to connect all the points that correspond to each other, and what you'll observe is that all these lines, they coincide at a particular point. And like I was about to say, my diagram, because of what I did with R prime, those points, that unique point where all the lines coincide, looks a little off from the origin, but is actually supposed to be at the origin. So for those of us who did do the graph with the images, you all would observe that. And for those of us who are just sketching, you will still notice that all the lines coincide at a specific point. That specific point is your center of enlargement. Alright? So the blue dot, let's do that again, take 2. Yes, the blue dot. The blue dot, where all those lines coincide, will be your center of enlargement. Alright? So this is where my center of enlargement will occur. And like I was saying, simply because of my lovely skill, that's the only reason why it's not at the origin exactly. Alright? But the center of enlargement in this particular problem is the origin, which we state the coordinates of. Alright? So anytime you're dealing with a problem that involves an enlargement, or in the case of a dilation, you should have a center through which this transformation occurs, and you must be able to identify it. And the good thing about, the enlargements and dilations is that it's pretty easy to get your center by doing this little thing here where you connect corresponding points to each other and you find where they all coincide. Alright? The center of enlargement, once you state the coordinates of the center, and the next part that we need to do now, which is our matrix, because we've already talked about the scale factor. We've talked about the orientation of the shape and how that influences the type of scale factor that we have. So now let's talk about the matrix itself. Alright? The general scale factor, well, I will call it a scale factor matrix, right? But the general matrix for enlargement, it resembles your the identity matrix, just like we've been seeing with all the other matrices we were looking at. The the reflection matrices, right? The reflection matrices that we were discussing the other day. We saw how they were all derived from the identity matrix. And the reason why I would always sort of reconnect back to that is that way, if you have a hard time remembering it, you're able to kind of go back to the identity and get it. Alright? So just like we were dealing with the points the other day, and I was showing you how you could, kind of work backwards and get your matrix, you could do the same sort of thing. Okay? So if it is I'm transforming my point, let's take the point minus 3 minus 2, right? If I'm transforming this point so that it becomes, the transform point is 6, 4. In this case, the only thing that's going to be different is the fact that we have a scale factor. So you notice that we have minus 3 had to be doubled, but also because of the orientation, we had to multiply by minus 2. So that way we would get the transformed x coordinate. And because we want to make sure that we get the transform coordinate as just positive 6, the next element in this row should be 0. Right? And again, it's the same thing that we're going to do in the second row of this matrix. You'll have 0 because we want to transform the y coordinate here. Alright, so this is what our enlargement matrix would look like. -2, 0, -2, and this is for this particular problem. Alright, so if I want to talk about a general enlargement matrix, once I know the scale factor in general, my enlargement matrix would look something like this, without that weird bracket. Alright, so once you know your scale factor K, you'll be able to get your enlargement matrix. Alright, so as you can see from this is like a scale factor of K times your identity matrix. Alright, so K is a scalar, obviously. It's just a magnitude that we've used to enlarge the shape by, and once you could do a scalar multiplication, you'll be able to obtain your enlargement matrix for absolutely any problem that you get of this nature in question. Alright, and you could actually use your enlargement matrix, and you could test out your matrix to make sure that you did the correct thing. And the one thing that I've always I was talking to some of my colleagues about it week before, and enlargement matrix is one of the easiest matrices to remember when dealing with transformations, because it's literally just scale factor 0, 0, scale factor. So once you know your scale factor, you'll be able to get your enlargement matrix. Alright, so if we have to, so let's go back to the question actually, because I ended up doing everything one time. Alright, because they're asking here to describe fully the transformation G which maps triangle PQR onto triangle P'Q', R'. Alright, here, if we had to state what transformation occurred, we'd say it was an enlargement of scale factor -2 through a center of enlargement 0, 0. Right? So those three things that we discussed here and were able to confirm, those three things will be used when you state your complete transformation which occurred to take us from PQR to P'Q', R'. Alright? And that same information that we were able to obtain just by looking at the diagram, we can use that now to further continue this and get your transformation matrix here. Alright? So in general, you have your scale factor of K for absolutely any enlargement or dilation, and once you have that, remember your identity matrix, multiply your identity matrix by your scale factor, and you'll be able to get your enlargement matrix. Alright, so before we continue with the rest of the question, anybody has any questions about this particular thing that we did here with the enlargement of PQR? We just absorb in right now. Absorb in. Alright, so, okay. So, you'll internalize it. Take your time and internalize it. And like I said, I'll have the recording available for you, so you'll be able to go back through this. Okay? And that's essentially enlargement matrix we discussed here.